Hello everyone! Today we're going to be taking a look at graphing parabolas in two different forms. So vertex or intercept form. And for this you're going to need your notes as well as a calculator. So please wait until the little pencil appears to tell you what you need to write down. This is a review of what we've been doing. We've been graphing in standard form. So this is an example of a quadratic equation that would graph into a parabola. And we need to use the vertex to help us get this graph started. And to find the vertex, we would figure out what negative b over 2a is. And then we would take that x value or that x coordinate and plug it in here to generate the y part of the vertex. And we've been working on making tables where that negative b over 2a x value goes in the middle of the table, and we can generate y values then that help us make the graph of this parabola. This is what our work looked like when we were talking about graphing in standard form. So we use negative b over 2a to find the middle x value in my table, or the x value of the vertex, and then we generated the table that would help us graph that parabola. Well, today we're going to take a look at two different forms. One of them is vertex form. So remember a while ago when we talked about absolute value graphs, they had some shifting involved in how that vertex moved across the graph. The same sort of idea happens with a parabola. So remember when we looked at this absolute value x plus 2, we said, hey, this little part right here tells me that that vertex is going to go up 2 units from 0, 0. Same is true when you have a parabola. Parabolas don't have absolute values in them, but they have an x squared. There's a plus 2 at the end right here. That's telling me we're going to go up 2 with our vertex. With the absolute value when we subtracted on the outside like this, that told me I went down 4 with the vertex. Same idea with the parabola, down 2 with this vertex. Then inside the absolute values told me if I moved left or right. This one actually went right 5. And the same is true when you look at the parabola. When the parabola is written as x minus 5 quantity squared, this is telling me inside those parentheses that this parabola's vertex also moves to the right 5. And so a plus 5 inside the absolute value told me that I was moving to the left 5. And same idea here with my parabola, and so on. When we had a negative out in front of an absolute value graph, we knew that that flipped that v upside down. Same idea with the parabola. We're talking about flipping things upside down. That parabola is going to go upside down. So this idea of using the clues for that vertex location is what we want to focus on. This part you need to get in your notes. How do I graph a parabola in vertex form? This is what it's going to look like. You're going to have y equals, or sometimes you might see f of x right here. That's just another name to name, or another way to name the function. That's function notation. There might be a number a in front. Sometimes there were numbers in front of their absolute values. Now there are numbers in front of our parentheses here, quantity squared. So inside again tells me how I move left or right, and outside tells me how I move up or down. So shifting the parabola's vertex h units horizontally, left and right, k units vertically, up and down. So this vertex form will tell us that location of the vertex without us doing negative b over 2a, because we don't have something in standard form. So let's do one where we're graphing once it's given to us in vertex form. This is vertex form, I can tell, because it's not all multiplied out into standard form. I also see the clues in that thing that we just wrote in that little formula with the A's and the H's and the K's. It looks similar to that. So when I take a look at this equation here, I'm going to use the clues to help me find the vertex. This part right here inside tells me that my vertex is moving right 3. Outside is telling me that it's moving down 5, and that will give me my vertex location. So I'll go ahead and plot that on the graph. Right 3, down 5 would be this spot right here, 3, negative 5. So I already know the vertex is 3, negative 5. I already know the middle point in my table is 3, negative 5. Now I need to find a couple side points to help me draw the sides of this U shape. So you can choose values on either side of 3. For x values, either side of 3. So I could do 2 and 4, or I could do 1 and 5. I could do all of them if I wanted to. Whatever you need to do here, but you need to get a couple spots on the side. Be careful to understand that this 1/2 that's in front is not the slope here. Okay, it's not a slope that we just plot up 1 over 2. We want to be careful about that because U-shapes are not linear in any shape or form. Okay, so they don't have a slope. We need to think about now plugging in the numbers that we're choosing. Maybe that's the 2 and the 4 or the 1 and the 5. We plug them in to our original equation to generate the y values that go with it. So 1/2, 1 minus 3 squared minus 5. If I plug in the 1, go ahead and type all this in the calculator. If you don't, if you do it in your head, make sure that you start in here with the parentheses, PEMDAS, parentheses, exponents, then multiplying, then adding or subtracting. So this becomes negative 2 squared is 4 times 1/2 is 2 minus 5 is negative 3. And if I plug in a 2, 2 minus 3 is 1 times, or take it to the squared, or squared, sorry. 1 squared is 1 times 1/2 is 1/2. 1/2 minus 5 is negative 4.5. We already figured out the vertex just by following the clues, and we know what these other 2 points should be based on the symmetry. So we go ahead and plot this now and see the rest of our parabola emerge. So 1, negative 3, 2, negative 4.5, 4, negative 4.5, and 5, negative 3. Here we go. There's my parabola. So once again, the key features of this parabola: the domain is all reals. The range is a description of what the y values are doing. It looks like the y's go down to negative 5 and then they come back up. So y is greater than or equal to negative 5. The axis of symmetry is where we would fold the parabola. We would fold him right here, right along that 3 on the x-axis. So the axis of symmetry is x equals 3. Is there a minimum or a maximum value? There's a low spot on this parabola, a minimum. And how low does it go? Where y equals negative 5 is the low spot. Now the increasing and decreasing intervals. Remember driving the little car. It's increasing, it's decreasing. What parts of the graph? If I drive the little car over here, here's my little car, he'd be decreasing right here until the x value of 3. So I'm decreasing from negative infinity to 3. Close the interval notation. Then at 3, it starts to increase. So I'm increasing from 3 to positive infinity. Close the interval notation. Okay, so that's graphing in vertex form. Now there is another form, intercept form. How do I graph a parabola written in intercept form? So when a parabola is factored, when it's split apart, that's why we spent so much time factoring. When it's factored, it's called intercept form. So it's going to look like this general setup here. Y equals, there might be a number in front, then there might be a couple sets of parentheses like this. This is what we're looking for. Okay, this general look. It doesn't have the same look as vertex form. It has 2 sets of parentheses here that are going to give us some clues. So we're going to solve each factored piece to reveal the x-intercepts or the solutions and use that to help make a small table. So we're going to reveal those x-intercept points, and that's going to help us out in finishing up a small little table. Okay. Go ahead and take a minute and write that down. Let's take a look at one example like this. We are going to graph this guy in intercept form. So this one is in factored form. He doesn't look like the vertex form. He doesn't have the little squared. He doesn't have the shifting that we can pull from it. But we can take his form and work with him based on what we see. So when it's in this form, we basically solve each little factor. So we say x plus 3 equals 0. What's my solution? x equals -3. I'm going to circle that. X minus 1 equals 0. What's the solution? X equals 1. These two right here are x-intercepts. So we know two spots on the x-axis that this parabola goes through. We know he goes through at -3, and we know he goes through at +1. These are the two side points of the parabola. But where's the vertex? Where's the middle part of the U? Does he go like this? Does he go like this? Does he go like this? There's a lot of parabolas that we could draw through those two side points. So we still need to figure out that vertex spot or that spot in the middle, and then we're pretty much done. So one spot at -3, one spot at 1, these are my two side points. So I already know that I have -3, 0 as a spot in my table, and 1, 0 is a spot in my table, according to what I have plotted. And I need to know that vertex point right there. Well, let's think about how we might figure that out. If we were going to fold this parabola in half, where would that vertex spot have to be? If we were going to take these two sides and bring them together. If I was going to fold him in half, it would have to go through this spot right here. -1 is halfway in between -3 and +1. So -1 is going to be the x-coordinate of my vertex. Now that doesn't mean I put a dot right here and go, hey, that's a parabola, because it's not. Okay, that means somewhere on -1 is where my parabola's vertex is going to be. Where? Well, we need to take that -1 and plug it in to generate that y value. So if I plug it into the equation where the x's are, x plus 3 times the x value minus 1, I'll generate that y value. This is 2, this is -2, so 2 times -2 makes -4. So the y part of that vertex is -4. So I know that my parabola's point is -1, -4 for the vertex. Now I have the bottom of the parabola here, and I have two side points, so I can go ahead and connect them to draw my picture of my parabola. Okay. So once again, once we have it plotted, we don't need 5 points in the table here. If we can generate a nice looking parabola like we're doing, we don't have to fill out the whole table. We just need those three things, two side points and a vertex. So the domain again is all reals. The range here looks like we go down to -4, so y is greater than or equal to -4. The vertex we just said is at -1, -4. The axis of symmetry, we would fold on the line where x equals -1. If we folded him in half, he'd be right there. Does he have a minimum or a maximum value? He has a low spot. How low does he go? Down to where y equals -4. And once again, our increasing and decreasing intervals, picture the little car. I'm driving the little car right here. He's going to go down until the x value of -1. So from -infinity to -1 is my decreasing interval. My increasing interval would be from -1 then to +infinity. Okay. So these are two different looking forms that we're using to graph parabola. Sometimes people like to graph in standard form and standard form only. You know, you can change from any of these forms into standard form. Please take a minute and write this down in your notes. All it means is that you would have to multiply it all out to get it to look like that standard form equation. So basically, it's just a little bit more work, essentially. If you want to turn every form into standard form, you have to take those extra steps. This one says y equals 3 times x minus 4 times x plus 6. How would we multiply this out? Well, we'd probably start by taking 3 times the x minus 4 first. That's 3x minus 12. And then we drop that answer down next to the x plus 6 and distribute again. 3x squared plus 18x minus 12x. 12 times 6, 72, -72. And then we go ahead and we combine like terms. 3x squared plus 6x minus 72. Drop down the y. So that factored form or intercept form intercept form into standard form simply requires us to multiply all those things out. So we can always convert into standard form if we want to or need to. Okay, so we're going to continue practicing on these different types of forms and being able to identify the key features from graphs. Thank you very much for taking good notes today.